Today we're going to go over position, displacement, and average velocity with free fall acceleration. So I believe we've talked a bit about vectors in uh, in the past. So we're going to skip a little bit of the vectors ideas here, um, but displacement is has to do with the direction that something is going in. So it isn't just the distance itself. Uh, we can talk about displacement in the negative direction or the positive direction. So if we go to the right, we have positive displacement. If we go to the left, we have negative displacement. This is going to be true for 90% of the coordinate systems that we see. Sometimes the coordinate system will be the other direction, but most likely that's not going to be. It's going to be right is positive and left is negative. We can write the change in displacement as delta x is x2 minus x1, or our second position minus our first position is going to give us the total displacement. We also have things called position time graphs. And so we put time on the x-axis and position on the y-axis. And what these graphs tell us is where something is located after a certain amount of time. So here we can see that at 3 seconds, this armadillo is at a 0 displacement. So we could put 0 on the number line, and that's where it would be. After 4 seconds, it's at 2 meters of displacement. Our displacement is in meters. We can see that here from the y-axis. And displacement can be negative, so the armadillo is at -5 there as well. Now, our average velocity, how fast something is going, depends on the displacement. So we take our change in displacement, we subtract the second position from the first position, and we divide by our change in time. So we get change in x over change in time, or delta x over delta t gives us our average velocity. And here, if we plot this same graph, again, we can see that the average velocity is a straight line. If we're starting and we're checking at 1 second, the displacement at 1 second was -4, and the displacement at 4 seconds is 2. And so we can find with this equation the average velocity between the two. And the average velocity is essentially just the slope. So the slope of a line is the rise over the run. So if we look at here, we're starting here and we're going up to here. So our rise, we end up rising up 6 units. And we're going over 3 units. And so our slope, or our average velocity, we can say is 2 meters per second. So this is our change in our y, and this is our change in our x coordinates, except in physics, in physics, when we're talking about displacement and time, position versus time graphs, the time is on the x, and so it's actually going to be change in t is our x, and then the distance is our y. So we could write that change in x, or we can write it change in d for displacement if we wanted to, just to not get confused with our original slope equation. The average speed has to do with the total distance covered divided by time. Now, distance is a little bit different than displacement. If we move on a number line, here's 0, 5, and -5. If we move from 0 to -5, our displacement is -5. And if this is in meters, we can say it's -5 meters. But our distance that we traveled is +5. Distance always is going to be positive. So another example would be if we want to find our total displacement, uh, if we went from 0 to 5 and then back to 0, our total displacement is 0 still. Our total distance, if we go from 0 to 5 back to 0, is 5. And then we went back 5, but distance always has to be positive. And so this total distance is going to be 5 more, giving us a total distance of 10. So our displacement is going to be 0, and our distance is 10. So that's the difference between those two terms. So the speed we write as s usually. The average speed is our total distance divided by time. Let's look at an example problem. This is an interesting problem. So this problem has to do with driving down the road and walking. And we're going to be able to differentiate between displacement and distance and calculating some average times of these different quantities. So we're driving down the road in a truck, and we're going about 8.4 kilometers, and we're traveling at 70 kilometers per hour. Then the truck runs out of gas and it stops. Over the next 30 minutes, we walk another 2 kilometers along the road to a gas station. We want to find for part A what's the overall displacement from the beginning of the drive to our arrival at the gas station. So our x1 is going to be our starting value, our displacement. We're starting at 0, and we end up at the gas station. We drove for 8.4 kilometers and had to walk for 2 kilometers. So our total, our ending position, I should say, x1 is our position for the beginning, x2 is our position for the end, is 10.4 for our ending position. Then we can find the difference between the two to figure out our total displacement. So this is position number 1, position number 2. Subtract between the two, we get our total displacement. Here, this is an easy problem. It's just 10.4 minus 0, and we get 10.4 for our kilometers for our total displacement. Now we want to find what's the time interval from the beginning of our drive to the arrival at the station. So we found part A. That part wasn't too bad. It just says what's the overall displacement from start to finish, from the beginning to the gas station. The next one says what's the time interval from the beginning of our drive to the arrival at the gas station. So now we have to look at the given information. We have to figure out the total time. So we were walking for a half an hour. The drive time was 70 kilometers per hour, and we drove 8.4 kilometers. This is the displacement of the drive only. So we can now find the average velocity of our drive. So we can find the displacement of the drive divided by the time that we were driving. And that's how we find average velocity. Displacement divided by time. All right. Actually, I think it's distance divided by time. That's our average speed. Average velocity, though, is the average velocity is a bit different because it has to do with the direction of our displacement, or because our average velocity can be negative. Here we're going in the positive direction, so we're doing displacement divided by time. Now our average velocity during the drive is 70 kilometers per hour. and our displacement during the drive is 8.4 kilometers. And we're going to divide that by the time. We just do a simple couple of steps here and solve this algebraically. Kilometers and kilometers end up canceling out, and we get a total drive time of 0.12 hours. So now we have our total driving time. Now we want to figure out what's our total time altogether driving and walking. So our change in time is equal to our drive time plus our walk time, 0.12 hours plus 0.5 hours. Make sure these are both in terms of hours, or you can do minutes, that's fine. But I think it would be best if you change everything to hours, just because we're talking about kilometers per hour. Leaving it in hours would be a good idea. All right, so that's part B. We just wanted to find the time interval from the start of our trip until we got to the gas station. Now we're going to go a step further. Part C says, what is the average velocity from the beginning of our drive to when we arrive at the gas station? So here's a graph of what is happening here. So we're starting out driving. Our position is changing very quickly because we're driving faster than if we were walking. And then the truck runs out of gas at about here. And then we have to walk for a much longer time. And we don't cover very much ground. We can see on the y-axis here. So we want to find our average velocity from start to finish. And to do that, we're going to find our total displacement, which is 10.4 kilometers, divided by our total time, which we calculated in part B, 0.62. So we do our total displacement divided by our total time, and we get 16.77 kilometers per hour for our average velocity for the entire trip. So we were going very fast while we were driving. We were going 70 kilometers per hour. But it doesn't specifically tell us how many kilometers per hour we were walking, but we can find our average velocity. So we're on average, we're going 16.77 kilometers per hour during that whole time. Now part D says, after we get the gas and pay for it and walk back to the truck, it takes us another 45 minutes total. What is the average speed from the beginning of our drive until we return to the truck? So now we are walking back to the truck. Our displacement is returning back here, but it's asking for now average speed. So we're still covering more distance, even though we're walking back in the negative direction. We're talking about distance now. So we're covering more distance. So it takes us 45 more minutes, it says, to walk back to the truck. And that truck walk is 2 kilometers away. So our average speed is total distance divided by time. So we've already calculated that it took us 0.62 hours to get to the gas station, to drive and walk. And then 45 minutes is 0.75 hours. So we're going to add all three of those together, and we get 1.37 hours for our total time that it took us to start driving, to walk to the gas station, and to walk back to the truck. So it's 1.37 hours to do that. And now our total distance is what we have to find. So our total distance is 8.4 driving, 2 walking, and another 2 walking back, giving us 12.4 kilometers of a total distance. So now our total distance is 12.4 kilometers divided by, and we're going to divide that by our change in time, which is 1.37 hours altogether, giving us an average speed for our total trip from the start of driving the truck to getting the gas to bringing the gas back. Our average speed was only 9.1 kilometers per hour. All right, these are the questions that are associated in the workbook with the questions that we just went over for this section.